In this video, we will learn how to factor trinomials with other leading coefficients other than 1. So in the prior video, we had trinomials, but this first term had a coefficient of 1, and that was a little bit slicker because we didn't have to worry about this coefficient affecting these other terms when we multiply through multiplying two binomials. So there's really two strategies we can use. I think they're kind of interchangeable. I don't think one's better than the other. But this first way we're going to go about solving this question here, factoring 2z squared plus 9z plus 10, is called factor by grouping. And we can kind of just manipulate this trinomial into a polynomial of 4 terms, splitting up this 9z into 2 terms, where the 2 terms we choose are going to be compatible with this 2z squared and this 10. Okay, so let's really look at this. If we look at that 9z, we can split this into 2 numbers when added, give us 9z, or 2 terms when added, give us 9z. But I'm going to take into consideration this 2 and this 10. Right, so say I did, say I broke this into a 1z and an 8z. Right, because 1z plus 8z give me 9z if I added those 2 terms together. Let me rewrite that a little bit cleaner. But now if I look at these terms of 2 and 1, 2z squared and 1z, the only factor they share is z. And if I look at 8z and 10, the only factors that these terms share are 2. So it's not very compatible. Okay, so if we look, and really taking into consideration here these other 2 numbers, I'm going to break 9z into a 4z plus 5z. Right, because now if I bring down this 2z squared plus 4z plus 5z, and then bring down this 10. Now if I look here and I want to look at these 2 sets of terms, these 2 and these 2, and I want to factor out common factors among these terms. So 2z squared and 4z, they share a factor of 2z. And then to get that 2z squared plus 4z back, 2z times z gives me 2z squared, and 2z times 2 gives me 4z. Now I'm going to do the same thing with this 5z and 10. I can factor out a 5 here. And 5 times what gives me 5z back would be a z. And 5 times 2 would give me that 10. So notice here how the factors that are in parentheses are the same. See how I have z plus 2 and z plus 2? That's a factor of, that's a common factor here. So that's going to be a factor of this 2z squared plus 9z plus 10. So I'm just going to write that in purple just to keep our colors kind of similar. Z plus 2 is in both factors here, so I'm going to write that in purple. Z plus 2 in parentheses. And then I'm going to highlight the coefficients of both of those of this factor is 2z and a positive 5. So that's going to be my other factor. Right here I have 2z plus 5. So this is called factoring by grouping. Okay, and it can be super useful. I don't know if it's any faster than this next way I'm going to be teaching, but it's definitely a good tool to have on your tool belt as you continue on here. Good news is if you had this type of question on the GED, chances are it will be multiple choice anyways, so you could work backwards from your choices. But there is definitely something to say, right, by starting with a problem and being able to factor it cold turkey. I'm not discrediting that. I'm just saying you'll have some other options on most assessments too. So that's one strategy. That's called factoring by grouping. Another strategy is trial and error. There's nothing wrong with trial and error when we're working through factoring trinomials with this coefficient that's not 1. So 2z squared plus 9z plus 10. You pretty much can outline it like I showed in the last video with just these 2 parentheses, because I'm going to have 2 binomials being multiplied. And to get that first term, 2z squared, I know that has to be 2z and z. There's no 2 other factors when multiplies that give me 2z squared, right? Now, the order could be changed. I could have put, I'm just going to rewrite that z. I could have put this 2z over here and this z here. I could have definitely changed up the order, but you just kind of commit to one or the next. If it works, great. If it doesn't, then we'll have to erase it. Okay. Now I want to look at my last term here of 10, right? I want factors of 10, right? So it could be 1 times 10 or 2 times 5. So I'm going to purposely put them in the wrong spot here just to prove a point. If I put 2 and 5 here, now we pretty much have to multiply these 2 binomials, trial and error, that's the whole point of it, to get this 9z, right? So if I multiply 2z times z, I get 2z squared. So that's looking great for my first term, right? Distribute this 2z through, I get 10z. I'm ignoring my signs for now. Here I have 2 times z is 2z, and 2 times 5 is 10. So the only thing that is great, it checks, is this 2z is right here, right? And this 10 and 10. But if we can see here, this 10z and 2, there's no way I can manipulate that by putting a negative and positive in front of each to get 9z, right? So that's where trial and error, this one's kind of debunked. That doesn't work now, right? So I'm going to just go back a bit. And instead of placing my 2 and 5 where I did, I'm going to switch that order, right? So I'm going to switch it to my 5 right here and my 2 here. So now let's multiply through here. 2z times z again gives me 2z squared. 2z times 2 gives me 4z. 5 times z gives me 5z. That's already looking good to get me 9, right? 4z and 5z. And 5 times 2 gives me 10. So just like the prior video, if I have all pluses, I can just put pluses in here. That would determine that these are pluses. And see now, I have my 9z here, and I have this 4z plus 5z. So here is 2z squared plus 9z plus 10. By trial and error, we can also factor that, right? We get the same thing right here, 2z plus 5 times z plus 2. It's the same thing right here, right? So there's really just, these are 2 methods. There's nothing wrong with trial and error. It can get a little frustrating. I would suggest to not erase so you remember what you've already tried. But if you're really efficient on multiplying binomials, there's frankly a lot you can do in your head too without writing it down. So just some options there. Let's work through another one. Let's do this one by grouping again. So let's look at this first term. And I want to split, the middle term, 10h. And I want to split 10h into 2 terms. And those 2 terms, I want them to be compatible with 3h squared and 7. So maybe you just see right away 3 and 7 give me 10. So that's exactly what I'm going to split this into. Okay, I'm just going to bring my 3h squared down. And I'm going to split 10h into 3h plus 7h plus 7. Now I'm going to look at my first 2 terms and ask myself, what is my greatest common factor among those terms? And I can factor out a 3h. To get 3h squared back, I would have h. And to get 3h back, I would have to have a 1 there. Now, same logic with 7h and 7. I want to factor out my GCF of 7h and 7. which would be 7. So I'm going to factor out a positive 7, and I get h plus 1. Okay, so this is pretty handy because I hope you guys can kind of see the connection that these have to be the same. The factors that are in your brackets here have to be the same. When they're the same, that means that that's a factor of this trinomial. Okay. So I know that h plus 1 is a factor. And my other factor is this 3h plus 7. So this would be 3h plus 7. So this trinomial 3h plus 10h plus 7 factors into this. Again, you can always check it, right? I can check and distribute this 3h through and the 7h through, and it should work out okay. Okay, this next one, 8u squared plus 68u plus 32. So first off, I think we can factor out our greatest common factor. Let's try that first. Between 8, 68, and 32, I think just 2. 2 can go into all of those. So 2 goes into 8 4 times. 2 goes into 68 34 times. And 2 goes into 32 16 times. So I am missing another, this 2 is not my greatest common factor, because see here how I have 4, 34, and 16, I know 2 can be pulled out of all those. So I'm going to erase that, and my greatest common factor must be 4. 4 goes into 8u squared, 2u squared times. 4 goes into 68 17 times. And 4 goes into 32 8 times. So that looks better because now I can't think of a common factor between 2, 17, and 8. So this is the first example where we actually factored out a greatest common factor first. So now let's just look at this trinomial and see if this can be factored anymore. So I'm going to go trial and error. I'm going to go over here. And I know my first term has to be 2u and u to get me 2u squared, right? Now my last term of each binomial has to be 2 numbers when multiplied give me 8. So I'm just going to try 1 and 8 to start. See if that gets me where I want to go. So I'm just going to check this in my head here. So I have 2u times u, 2u squared. 2u times 8, 16u. 1 times u is 1u. 1 times 8 is 8. So I got super lucky. I really did just guess. I need a 17u here. Notice here, this 16 and 1 can easily give me 17. So these are just both pluses. And that would determine here that 16 plus 1 gives me 17. So how we would rewrite this is 8u squared plus 68u plus 32. We first have to remember that we factored out this GCF of 4. And then this trinomial here factored into this. So it's 4 times 2u plus 1 times u plus 8. So this trinomial factored into 3 factors. Okay, so again, it's not as common, but it definitely is something you can see. So let's be careful of that. Next, we have more practice factoring out that GCF, because just looking at 5, 90, and 95, I can see that they all share a factor of 5. So I'm going to factor out my GCF of 5. 5 goes into 90, how many times? 18 times. And 5 must go into 95, 19 times, right? So if I look here, I can just bring my 5 down. And the reason I can just write it down a little bit quicker here than I did on this problem above is my coefficient here is now 1. like the last video we viewed. So I know that here and here just gives me S. I don't really have to go trial and error for this one because that leading coefficient is 1. So now I need to think of factors of 19, and there's only 2 factors of 19, and that's 19 and 1. So I need a positive 18, so that's going to go with my 19 and a minus 1, because 19 minus 1 gives me that 18. So 5s squared plus 90s minus 95 gives us that factored. So if you want, I would suggest viewing this video again. That factoring trinomials with a leading coefficient other than 1 can be tricky. But honestly, the best way to get better at it is just practice. So maybe watch this video again, work through some more examples, and then practice in IXL. And I promise you, you'll get good at it. It just takes time and effort.